Tara pre, start na tayo pre.
Hello everyone, we are here to present about shielded metal arc welding presented by Group 2. Next slide. What is SMAW? SMAW stands for shielded metal arc welding. SMAW is a type of welding used in a variety of applications, including maintenance and repair, construction, industrial fabrication, and more. Next. Shielded metal arc welding, or SMAW, also known as stick welding. It's a manual process using a flux-coated consumable electrode with a metal rod at the core. So this is what stick welding looks like, but the process of it will be discussed later on. And SMAW is one of the easiest and most versatile ways to weld. Since filler material can be easily changed to match different metals just by switching stick electrodes. Aside from that, stick welding is versatile because it takes the least equipment, which makes it easy to set up or move to a new location. Next. So stick welding takes its name from the shape of the electrode, which looks like a stick. So as we can see here in this image, it looks like a stick. So it can be used to weld many types of metals, including steel, stainless steel, and cast iron. Stick welding machines provides constant current or CC using direct current or DC or alternating current AC. Direct current operates in different directions based on the polarity. Alternating current switches between directions. Power in the electrical circuit used to power the weld is measured in amperes. More current or amperage is needed for welding thicker metals or electrodes. So when welding thinner metals or electrodes, it requires less amperes. So when we compare this stick welding to other types of welding, the power source of stick weldings are generally the least expensive. So as a result, they are utilized most often by novice welders and maintenance shops and field construction contractors that weld on a variety of jobs that is welding. So as we can see here, the electrode has something written on it, E6010. So the meaning of that is that the E stands for electrode, then the first two digits 60 represents the tensile strength of the electrode. So 60 meaning it provides 60,000 psi tensile strength. So the third digit, number 1, represents the position that is for welding. So number 1, so here in this electrode, number 1, all position for welding. So if the electrode has number 2 as its third digit, it is for flat or horizontal position welding only. And number 3 for flat, horizontal, vertical down, and overhead position. So the fourth digit is number 0. It refers to the coating type and the type of welding current. So this electrode 6010, it is used for all position of welding, and but it's only suitable for DC power source. Next. So these are the different positions in welding: flat, vertical, horizontal, and overhead. We can see here in flat position, the plates and axis of weld are horizontal. And horizontal position, plates vertical and axis of weld are horizontal. Vertical position, plates vertical and the axis of weld is vertical. Overhead position, plates and axis of weld is horizontal. So another thing is that this flat position, the axis of weld is vertical. Horizontal position, the axis of weld is horizontal. And in vertical position, axis of weld is vertical. Overhead position, axis of weld is horizontal. So as we can see here, there are different types of position that we can use in welding, but not all of it is suitable depending on the electrode that are being used in stick welding. Okay, next presenter.
So the process, SMAW or stick welding uses the arc heat to melt the base metal and tip of consumable electrode. The electrode and base metal are part of the electric circuit or welding circuit. So this circuit includes power source, welding cables, electric holder. Electric holder connects to the welding cable and conducts the welding current to the electrode. Then ground clamp or as they call earth clamp, this is used to use the right voltage when welding, and you use this to clamp in any metal surface or any kind of metal plating. Then next is work work or base metal. So these are the two metals that are being welded. The next are the arc welding electrode. Is a wire that connected at the end of your welder and creates an electric arc. So one cable is attached to the work and the other to the electrode holder. Next slide, please. Welding starts when an arc is struck between the tip of the electrode and base metal. The heat melts the tip and the surface of work. Tiny globules or small particles of molten metal form on the electrode tip, then transfer through the arc into the molten pool. Filler is deposited at the electrode is consumed. So this is the process of welding. Um, so you just only need to use the welder, point it at your at your base metal. Next slide, please. The arc welding SMAW or stick welding arc is moved at an appropriate arc length, approx equal to the electrode diameter. So when welding, you have to balance it out in a 90-degree angle. And next is the operate travel speed. You don't need to rush when welding. Just take your time when doing welding. Next slide, please. For welds made in the flat or the horizontal position, metal transfer is aided by gravity. In our in our in in out of position welds, the base metal is unable to retain much molten metal in the crater. Small electrodes, lower amperages, and lower arc lengths should be used. Next is gas expansion. Gases are produced by the melting of the electrode, coating and expand due to the heat of the boiling electrode. Next is electromagnetic forces. The tip of the electric conductor and so is the molten globule or at the tip. So the globule spray is altered by magnetic force acting at 90 degrees, sideways in most cases, to the direction of the current flow. Surface tension, the force keeping the filler metal and slag in contact with the molten base metal in the crater in surface tension. Next slide, please. Next presenter.
So the advantage and disadvantages of SMAW. So SMAW or stick welding requires basic equipment and lends itself to field work because it is extremely portable. So SMAW, or which we call stick welding has great advantages because we can use basic equipments here and it can lend itself to the field work, and it is really extremely portable. So here's some good advantages in SMAW. So the cost in SMAW is 30 to 50% cheaper of other welding methods. And the next one will be lightweight equipment. So we use the equipment is so very light that we can use it on. And I mean we can lift it properly. Next is many types of available electrodes. So there are a lot of types of electrodes in stick welding that we can use. Then next is good in tight spaces. Since it is a stick, it can be used at tight spaces, like an example in let's say in between the concretes that we have to that there's a metal that we need to weld in a between concretes which is tight, so we can use SMAW process. I mean SMAW here. Next is cleaning metal surface before welding, not as rigorous as others methods such as TIG. So the disadvantages of SMAW. Need to remove the slag after welding. Entrapment of slag is also as an issue as in SMAW forming inclusions, which need to be removed. So in when we're using SMAW, we always need to remove the slag, since it is always the slag always entrap in some conclusions, which is need to be removed. Next is unused electrode stubs need to stop welding when you reach the last 2 inches of the electrode. So when we're going to use SMAWs, we have to stop welding at the last 2 inches of electrode. And that's kind of bad because I mean let's say we the extras of these 2 inches can be used, but we have to stop welding when we reach the last 2 inches. Next is spatter, which when we're welding, the electrode stops spatters when we're using SMAW. Slow relative speed of SMAW. So next is spatter cleanup and slag removal labor intensive. So we have to always clean up the spatters that have been used in SMAW, and the slag creates more spark and heat than other welding methods. So SMAW has more sparks and it does a lot of it than other methods. Chipping and grinding completed welds give us a harmful dust. And the last will be need to stop during the welding process to replace used electrode to chip away the slag. That's all.